Hello there, welcome again to this video. For the continuation, for our example in separable variables, we have for number 3 and number 4. So for the number 3, we have 2y dy is equal to x squared plus 1 dx. Okay, so compare the number 3 and number 4. Number 3 is simpler compared to number 4. So we'll start with number 3 first. So because in number 3, variables are already separated, so we'll now integrate this one directly now. Okay, so the integral of 2y dy is equal to the integral of x squared plus 1 dx. So again, we will integrate this one directly because the variables are already separated. Okay, so the integral of 2y dy, so the rule is you have to add fraction. You have to add 1. So 1 plus 1 is 2. So what is written here must be written also in the denominator. So we have 2 is equal. So we can cancel this one. So next is this one, the integral of x squared plus 1. So we can separate dx, distribute dx plus the integral of dx. Okay. So y squared is equal to, the integral of this one is, you have to add 1. So 2 plus 1 is 3. Then what is the exponent is also 3 in the denominator. Okay, plus the integral of dx is simply x, then plus c. Okay, so that is our answer. This is the family of solutions, family of curves satisfying our differential equation 2y dy is equal to x squared plus 1 dx. Okay, next, for example number 4. So what we're gonna do here is we'll separate also the dx and also the y squared minus 4. So I will do first this one. I will multiply first dx both sides. So dy would be is equal to 2x plus 3 y squared minus 4 dx. Okay, so next we want to segregate y squared minus 4 because it is located here. It is found in the x families, so we'll put this one in the y families. So we will multiply again by 1 over y squared minus 4. Okay, so if you multiply this one, it will be cancelled out. And if you multiply this one to dy, it will become dy over y squared minus 4 is equal to 2x plus 3 dx. Okay, so since it is already separated, the variables are already separated, we can now integrate the both sides of our equation. So integral of for your RHS and the integral of your LHS. Okay, so obviously our left hand side is more complicated compared to our right hand side. So we'll integrate first in our right hand side. So the integral of this one is x squared plus 3x plus c. How about in our left hand side, which is dy y squared minus 4. So if the form of an integral in this form means the denominator can be factored out, we can write this one as dy over y plus 2 y minus 2 excuse me. The best method to find this, the solution here, or the answer here, is we will do the partial fraction. So the partial fraction, we will remove first our dy, so we'll ignore that first. So y is plus 2 y minus 2. We have to factor our denominator, then y plus 2. We'll put some a as our constant, then b y minus 2. Okay, so next we'll multiply both sides by y plus 2 y minus 2. So here, So multiply in our left hand side, this will be cancelled out, 1 will be remaining. And next here for your right hand side, a y plus 2 would be cancelled out, so y minus 2. Then for b, y minus 2 would be cancelled out, so y plus 2. Now we will solve the value of a and b, of course. So how to do this one? To do that one, we will let y is equal to 2, positive 2. And look what will happen if I will make y is equal to 2. So a 2 minus 2 plus b 2 plus 2. So this will be 0. 1 plus 0 is equal to 1 plus 0. 1 equals to 0 plus 4b. So from here 1 is equal to 4b, and it follows that b is equal to 1/4, positive 1/4. Okay, to take to this one. The next, we will let y is equal to negative 2. So 1 is equal to a negative 2 minus 2 plus b negative 2 plus 2. So this time our b would be 0, would become 0. So 0, 1 is equal to negative 4a. It follows that a is equal to negative 1/4. Okay? So we can now solve our integral. So we can write the integral here as the integral of RA is, again, that is positive 1/4, negative 1/4, okay, rather, this negative 1/4, negative 1/4 over y plus 2 plus 1/4, b is positive 1/4, y minus 2 dy is equal to x squared plus 3x plus c. Okay, so we'll integrate this one, this left hand side. So negative 1/4, the integral of dy y plus 2 plus 1/4 dy y minus 2. We will put 1/4 outside of the integral sign because 1/4 is a constant. We will not include that one in integrating. So it's equal to x squared plus 3x plus c. Okay, next is the integral of this one. Is very familiar. We let u y plus 2 for the first term. Let u is equal to y plus 2, so it becomes du over u. So what will happen is 1/4 ln u y plus 2 plus 1/4. The same thing in the first term, ln y minus 2 is equal to x squared plus 3x plus c. Okay, now we'll multiply this one both sides by 4 to dissolve our fraction. So 4, so it will become negative ln y plus 2 plus ln y minus 2 is equal to 4x squared plus 12x plus c sub 1, where c sub 1 is equal to 4c. Okay, anyway, it's just a constant. You can remain that one as a constant. So what happened is we have negative ln y plus 2 plus ln y minus 2 is equal to 4x squared plus 12x plus c sub 1. Okay, now by properties of logarithm, since we have the negative sign here, we will use the quotient rule in logarithm, or the quotient property. So we have ln, we'll divide the arguments. So ln y plus 2 ln y minus 2 rather is y minus 2, y plus 2 denominator must be here, then 4x squared plus 12x plus c sub 1. Okay, so next is we will dissolve our ln by raising both sides to the power of e. Okay, to the power of e because we have the base e here, and if you raise both sides by e, this ln would be cancelled. Okay, so what would be the remaining is y minus 2 all over y plus 2 is equal to e to the power of 4x squared plus 12x plus c sub 1. Okay, next we can write this one as y minus 2 over y plus 2 e to the power of 4x squared plus 12x times e to the power of c sub 1. Remember the product rule in exponent. If plus, we have to that means we have to multiply the base. So it can be written as a to the power of 4x squared plus 12x times c sub 2, where c sub 2 is equal to e to the power of c sub 1. So y minus 2 y over y plus 2. So now it will become y minus 2 y plus 2 is equal to c sub 2 e to the power of 4x squared plus 12x. Okay, so we are not yet done here because we will solve it further. We can solve it further in terms of y. So we'll go up here. So y plus 2, y minus 2 rather, all over y plus 2 over c sub 2 e to the power of 4x squared plus 12x. Okay, notice that we can dissolve this fraction by multiplying both sides by y plus 2. So the remaining would be, it would become y plus 2 c sub 2 e to the power of 4x squared plus 12x. Okay, now we can distribute this one. We can distribute this one here because it's the binomial. So y minus 2 is equal to y c sub 2 e to the power of 4x squared plus 12x. The next plus 2 c sub 2 e to the power of 4x squared plus 12x. Okay, now we can separate this one. We can simplify this one further. We will segregate y, this y, and also our constant 2. We'll put our constant 2 here in our right hand side, and the y will be in our left hand side. So y minus y, this one, c sub 2 e to the power of 4x squared plus 12x is equal to this one, 2 c sub 2 e to the power of 4x squared plus 12x. Of course, we have our plus 2. Okay, so we can factor out y here in our left hand side. So this can be written as y. The remaining would be 1. Then here is minus c sub 2 e the power of 4x squared plus 12x, or 2 plus 2 c sub 2 e to the power of 4x squared plus 12x. So we can divide this on both sides. So you can solve this one in terms of y. So this become y is equal to 2 plus 2 c sub 2 e to the power of 4x squared plus 12x all over 1 minus c sub 2 e to the power of 4x squared plus 12x. Okay? So this will be our final answer.